Okay, good morning, Year 13. Feels a little bit weird speaking to you through a screen, but in these circumstances, obviously we've got to adapt and develop, and that's what we're going to do here. What a week last week was, very emotional. I'm sure a lot of you sort of feeling mixed emotions about the exam situation. Just want to give you a bit of an update regarding maths, and obviously how your grades are going to be allocated are different to how they were. You're not going to sit the exam this summer. What we're going to do in maths, and I think all subjects probably follow a similar path, is we're going to use all the evidence that we've got on you over the past two years, possibly even before that, and look at how people similar to you in the past have done. So this won't be just looking at your predicted grades, but it also won't be looking at your mock results either. It will be looking at a range of data we have on you, the end of year 12 exams, the mock exams, and also how people tend to improve from their mocks into the summer. Finally, what we're going to look at is your work from now, because obviously what you do now, what you would have done in terms of revision, is a big indicator into what sort of grade you would achieve. So in order to do that, we need to build sort of a body of evidence, really. So you're going to have to continue lessons as normal, and please submit every piece of work you do via an image or a scan. What I'm going to do is I've got a folder for every one of you, and I'm just going to be storing all those emails that you send me with all your work. So then I've got a big body of evidence to support any grade that you may be fighting for. If you don't do the work, simply that evidence won't be there, and then it'll just be a harder case of you getting the grade that you might want. The other way of doing it is to do. I'm going to be setting work from Dr. Frost as well. Do bear with it for the first few days. I know he's struggling with the increased traffic at the moment, but that will get better with time. And also any independent work you do through Dr. Frost, or any past papers that you may do, which I'd encourage you to still keep doing them. Please just keep emailing me with your scanned work. That is so important. The more work you do and the more evidence to show that you're still working hard, that's just easy for me then to say, yes, they are going to work hard. They would have improved their grade by this amount. I mean, if you don't do it, then I just have no justification to do that. So that is really important. So just continue as normal, really, and we'll be fine. Now, do keep emailing me. Obviously, I'm a bit new to this sort of YouTube phenomenon. So please comment in the comments below if I can improve these videos in any way, and also email my school email as well if you need any help or any advice on anything, really. I'll try and help as much as I can. But it was great to see you on Thursday last week. I think I saw most of you, and obviously I'll do stay in touch, and certainly come back for any leavers event that might happen. We'll sort of do a proper, more formal goodbye then. But until then, it is really important you carry on as normal. And that starts with today's lesson. So we're going to treat it as a normal lesson, and here we go. Okay, guys, we're going to start with one of these starters. So please do this on paper. Even these sort of activities, I would like you to scan in and send at the end of the session. But I'm going to give you 10 minutes. I'm going to disappear in a minute, and off you go. Okay guys, and here are the answers coming up. Do pause and mark your own work. Here they are. Okay, today's session is on, we're going to carry on with mechanics, and it's going to be on variable acceleration using vectors. Okay, variable acceleration using vectors, and the date today is the 24th of March. Right, okay, now just going back to a bit of a recap. Now, as variable acceleration, we cannot use Suvat equations. Okay, can't use Suvat equations if it's variable acceleration. So we must use calculus, which is differentiation or integration, instead. Okay, and we looked at that in last year actually. Okay. Right, okay, so best thing to do is we need to sort of recap which route we need to go down. So we might start with a displacement vector, and that would go to velocity vector, which in turn would go to an acceleration vector. Okay, we don't need to go any further than that. Now, if you go down the chain, so to get from displacement to velocity to acceleration, you differentiate. And if you're going up the chain, so you're going from one to the next, you integrate. And please put in here, remember to include plus c when you integrate on these. So plus c, really, really important. Okay, we're going to look at a couple of examples, e.g. 1. Okay. Right, so the position vector r is equal to 2t cubed I plus 50 t to the minus a half j. Okay, that's the position vector of this particle. And the particle has a mass, so particle has a mass of 0.8 kilograms. Okay, right, now that's the example. This is from the book. If you want to refer to it, it is on page 171. We're looking at that example there. Now, question 1 is find the speed when t equals 4. Okay, that's question 1. Find the speed when t equals 4. Right, so far we've got a displacement vector. The r vector there is a displacement vector, and we need to go from the displacement vector to a velocity vector. So we're going to have to differentiate this. So we're going to have to differentiate this first. So we need to do dr dt, and that's the same as the velocity. And to do that, you just differentiate each bit separately. So 2t cubed, that's going to differentiate to 6t squared I, that's the direction I. And then if we differentiate this one, we get minus 25t to the negative 3/2 j. Okay, so that is our velocity vector. Yeah. Now, when t equals 4, our vector is, if I just substitute 4 into that equation, you can test it out, but you will get 96i minus 25 over 8j, again meters per second. Yeah. Now, it doesn't just ask for the velocity vector, it asks for the speed. So therefore, the speed, we have to use Pythagoras. So it's going to be 96 squared plus 25 squared, all rooted, and you'll see in the answer book that is equal to 96.1 meters per second. Okay, so that is how you work out the speed. You differentiate it and then sub it in, and then use Pythagoras after that. Right, let's look at another question. So the next bit is find the acceleration. So find acceleration as a vector when t equals 2. Okay, so again we follow the same procedure here. So we've got an equation there. This equation here is for velocity. So I need to differentiate that again. So it's in this case dv dt, change in velocity over change in time, and if I differentiate it again, I get, well, if I differentiate 90, if I differentiate, sorry, I need to differentiate this one, not the one below. I need to differentiate that one. So I'm going to get 12ti, and over here I'm going to get plus 75 over 2 t to the minus 5 over 2 j. That's my acceleration vector. And then quite simply, when t equals 2, I can just substitute that in. So dv dt will equal 24 plus, again it's a horrible number, but 6.63 j, and that's all meters per second squared. And you sometimes write that. Okay. And the final part of the question is find out the force. So find the force when t equals 2. Well, this is quite straightforward now because I know that F equals ma. So F equals, it told me in the question what the mass was. The mass was 0.8. Sorry, 0.8 times 24i plus 6.63 to the j. Which gives a force of 19.2 I plus 5.3 j newtons. Okay, right. That is differentiating vectors. And at this stage, I would want you to go to page 171. Exercise 8D, and I want you to do the evens. So that's question 2 to 10. And at this stage, I would probably pause the video if I were you, because in a minute I'm going to move on to the integrating vectors. But I want you to try and have a go at those questions first. So try and do those 5 questions there. See, you should be able to get through most of that in the lesson, and then obviously, if you need to then watch the next bit, that's fine. Okay, so pause it. If not, I'm going to carry on with the next type of question, which is integrating vectors. All right, again. Okay, so this is EG2. I'm going to look at the example on page 173, and it says this: a particle is moving in a plane so that at time its acceleration is 4i minus 2tj. Okay, so we know it's variable because it's relating to t there. So that's exception. And then it says this: when t equals 3, the velocity is equal to 6i. Okay, and the position vector, I'm going to call that r, is equal to 20i plus 3j. Right, okay, so part A is find the angle when the direction of motion, so we're trying to find the angle between the direction of motion of P and I when t is 2. So we're trying to find the direction of motion. Direction of motion, that to me indicates velocity, okay? I'm thinking velocity. Direction of motion, we're talking about velocity. So I've been given the acceleration vector. So to get from acceleration to velocity, I need to integrate my acceleration. But I'm going up the chain, so I'm going to be integrating my acceleration vector. And in order to do that, I just integrate each bit separately. So it's going to be 4ti minus 2t squared over 2j. Okay. That is my velocity. Very, very important. I put plus c at the end of that. Okay. So to get, I need to work out my c now. So I need to find my plus c, and I use the conditions that are given. I know that when t equals 3, v is 6i. So I use that and substitute in. So I know v is 6i when t is 3. So 4 times 3i minus, that's going to be t squared. So 3 squared j plus 6. Okay. Now, if you do simplify that a little bit, you get 6i equals 12i minus 9j. Case of rearranging this slightly, so you end up with c equaling minus 6i plus 9j. Okay. I can then fill in I can then work out what my velocity is. So my velocity is going to be 4ti minus t squared j plus 12i minus j. And quite often a tip here is to group I and j's together. So tip, group I and j together to get v's. 4t plus 12 plus 12 I plus minus t squared minus 9j. Now that is my formula for the velocity. And again, I go back to my question. It said when t equals 2, my velocity is, and if you plug in, you should end up with an answer being 2i plus 5j meters per second. Okay. It's a bit messy there, it should say meters per second. And the question was, work out the angle it makes with the I vector. So the I vector itself, a little sketch here is helpful. This is the vector, and the angle it's going at is 2 along, 5 up. It's going in that sort of angle. It's going 2 along the I and j, and it's that angle that it's up. So it's going to be shift. It's going to be the tan, because it's tan rule. So we know that tan theta equals 5 over 2, therefore theta equals tan to the minus 1, 5 over 2. In this case, that's going to be 60.2 degrees. Okay. Right, I'm not going to go through the next example because they're quite long, and I think you can probably have a read of these yourself. But what I do want you to do is the next exercise. So I want you to now do exercise 8e, and again I want you to do the evens, please. So the evens, so that's question 2 to 8 inclusive. Now, essentially what I really, by the end of this session, I want you to email me a scan of the starter activity completed and both these exercises completed, and I will be checking that. I'm always going to check it the following day, so that you need to do this for Wednesday, please. Please leave any comments or let me know if I can improve on these videos in any way. And good luck over the weeks ahead. Do stay in touch. It'll be fine. Just keep submitting work. All right, guys.